Alright, this is Tic-Tac-Toe. Welcome to Tic-Tac-Toe. This is a two-player game. Players will take turns marking the grid with their chosen symbol. First player to have 3 in a row is the winner. Player 1, please pick a symbol. I'll let you be player 1, Evan.
Perfect. I'll go with X.
Where would you like to put your first mark?
I'm going to go right in the center with 5.
I'm going to go with 3.
I'm going to go 1.
That's pretty sneaky, but I'm gonna have to stop that with a 9.
You know, I think it looks cool. I'm going to go 7.
Are you sure you want to go 7?
Spot. It looks like a good spot.
Alright, I'm going to go 6
Oh,
then.
no, it's not a good spot.
And I have a match. Good game.
Good win, good win. Let me get a retry, though.
Alright, let's do one more then. Alright, I'll be player 1 this time. I think winner gets the choice.
Okay, sounds good.
I'm gonna go with O.
O?
And I'll put mine in 5.
Okay, I'll put mine in 3.
And I'll go with 2.
2. I'm gonna go with 8.
Yeah. I'll go 6.
I'm gonna go with 4.
I'll go with 1.
I'll go with 9.
I guess I have to take 7 then.
It looks like a cat's game.
That's a draw. This is our data section. It stores all of the strings and characters that we're using for the program. It stores the strings as .ASCII and it stores characters as .byte. There are also 2 arrays here. We have this grid and this play grid. The grid is of type .word, which holds the numbers 1 to 9, and it represents, or it's going to hold the numbers for a numbered grid that we use as a legend. The play grid is of type .space9, which represents 9 empty bytes, and that's going to store the actual play grid where the players put their symbols.
So here is the beginning of our step 1 section. So this is the start of our .text section. Our program begins by setting the S0 register to 0 to be used as an index. Then we print a welcome message, and from here we prompt the player to choose their mark, so whether they want to choose X or O. The input for that is stored in the player 1 symbol function, and the character X or O are then loaded into temporary registers. 2 branch if equal statements check whether player 1 chose a symbol and gives the opposite symbol to player 2. If player 1 did not choose X or O, the program will pass the branch if equal statements and then jump back to the start of this section, again prompting player 1 to select a symbol. Once player 2 is given the opposite symbol, it then jumps to step 2.
So this is the start of step 2, which is the step where we're printing the numbered and the play grid. So we start with the print grid label here, and this function is essentially going to just print a numbered grid that represents the positions of where you could put your symbol on the play grid. So the first thing that we do is set an index, and we save 12 for division later on. We load the value, we start a loop, then we load the value of the index, the value of the array at the current index. We divide the index by 12 in order to check every 3 elements, because a .word is 4 bytes long. We need to check for every 12 bytes in order to actually print the grid as a 3 by 3 as opposed to just one long line. And then after we check that, we check that by dividing it by 12, and if it's divisible by 12, we actually just print a new row. We jump to this here. After that, we print the number that was there. We print a pipe to make a column. And then finally, we loop again, which is right here. We jump back to the start of the loop. And then once that loop's done, we reach 36, which is the last byte of our array, we jump to actually printing the play grid, which is the other grid, the other array that stores the play symbols. So let's go to that line, which is right here. So we save our index. This time we save 3 for later division, because we're checking every 3 bytes for a new line as opposed to every 12 bytes, because this grid is made, or this array rather, this play grid array is made up of the type.byte, or at least it's characters which are stored as bytes and not as words. So we start the loop here. We set a condition for it that says if we reach the 9th byte, we're done the loop and we want to start checking for a match. So that's what this checkload function will do. We check every 3 bytes to make a new line, like I said before. And then finally, if we do print a new line, or even if we don't print a new line, we still have to print the symbol, which is this function here. And this function also simply just checks the value of the array at the current index. If it is null, then it will print an underscore, which represents a blank space, so the player knows that they can put a symbol there. If it's an X, then you just print an X, and if it's an O, you print an O, and then you print a pipe to simulate having columns. And then you increment the index, and we jump all the way back to the start of this loop again, right here, until we get to that last byte. And finally, when we do get to the last byte, we jump to step 3, which is this checkload step.
So this is the beginning of our step 3 section. So after we print the grid, we check to see if there's a match, and from there we use the check load function. This function loads the elements of all 8 possible match positions, so the 8 possible ways someone can win on the tic-tac-toe grid. It sends them one at a time to a match check function. If a match is found, it will branch to a point where it displays who wins, and then the program will end. If no match is found, we jump and link to the tie check function. So we check for a tie by checking to see if every single element of the play grid is not null, meaning that every single space on the play grid is filled in with a value. And if so, a tie message is displayed. As soon as a null element is found, we can actually then skip to step 4.
So here is step 4 of our tic-tac-toe program. We end up here if it is determined that there is still a null element in the play grid, which means that there is still a space left for a player to put a mark. And there's also, we know, there's also no match at this point, so we know that the game has to continue. So we determine by checking the player counter which player's turn it currently is, and this is why the player counter also starts at 2, because once this is run, we want the first player to be player 1. So this will start at 2 and pass the turn to player 1 because of this. Because of this line, actually. If it's player 1 turns currently, then it will pass the turn to player 2. And all it does is it branches to 2 separate labels, which just handle if it's player 1 turn or if it's player 2's turn. And both of these functions work in pretty much the same way. All they're doing different is just changing which label they're jumping to in case of wrong input, which is player 1 move and player 2 move respectively. And also we are changing the symbol based on which player, because the players have 2 different symbols. So what we do is we prompt a player to choose a location for their mark. If they enter a number that's greater than 9 or less than 1, then we know that their position is invalid, because the numbers 1 to 9 are the only valid positions on a 3x3 grid, or on our 3x3 grid. We subtract 1 from their input to make it match the actual indexes of the elements of the play grid, 0 through 8 as opposed to 1 through 9. We then load the selected play grid location to check what's there. And if, for whatever reason, that player chose a spot which is not empty, aka we branch if that spot is not equal to 0 back to the beginning of player 1 move so that they can re-input something because they did not give us valid input. If their input was valid, which means that T1 was equal to 0, aka T1 was null, then we're going to load player 1's symbol, or player 2's symbol if it's their turn, into the play grid at the current index. The index they chose, sorry. Finally, we jump back to the turn cycle, which is step 2, which will be up here. Step 2. Step 2, turn cycle. We print the grid. After the grid is print, this condition will hit. We'll print the play grid, just down here. After we print the play grid, we have finished with step 2, so we're going to go to step 3, which is check load. Which is all the way down here. Step 3. Once we have loaded the indexes and done the match check for each one, then we're going to do a tie check if there is no match. And that's the end of step 3. We're going to jump back to determine player once we determine that there is a null element and there is no tie, and we need another turn. So we're going to jump back to step 4, which is determine player. And from here, as you can tell, we continue the loop over and over again. And eventually it will break because there is a tie or because there is a match. And a winner will be determined or a tie will be declared.
Thanks for a great semester, Bill and Kyle.
And I hope you guys have a really great summer.